Hey everyone, this is Subnet0 and welcome to my channel. So in this video, we will be focusing on subnetting, why it was created and how is it useful, and the entire conceptual introduction behind subnetting. Okay. So a major prerequisite for this video is that please all of you, if you have not understood the concept of CIDR, which is in my previous video, please go and first click that before you go ahead and proceed and watch this video, because if you have not understood the entire concept of CIDR, you will not understand a thing. So please, once again, go back to CIDR, watch it properly, and only if you have understood that and internalized that and done practice, then only proceed with watching this video. Okay. Yeah, so without wasting much time, let's get into what it is all about. So, before we get into subnetting, just to remind you what we are talking about. This is a still I've taken from the previous video. You see this. Let me just zoom in just a second. Yeah, you see this one in this pink circle. That is which a house. Okay, that I refer to as a house where inside all the private IP addresses are there. Okay. So this is what we are referring to, is the one in pink circle, okay? Let me ensure the color, I color this pink. Yeah, let me ensure I color this entire network pink. Yeah. So imagine this pink house that we spoke about in the previous one, this one. This this pink uh this pink circle or this pink house, okay? So imagine if that is a company that you have, okay? You have started a company where you have a set of 256 IP addresses. Yeah. And the private IP addresses, the entire range would be 192.168.0.1/24. And if you don't know what /24 is, please go to the previous video, understand the whole concept of CIDR properly, then only proceed with this video, or else please do not proceed. Okay. Yeah. So if let's say you have this, okay, and which means this will provide you 254 IP addresses. Why 254 IP addresses? I have explained that in the previous one, where the first one will be the network address, the last one will be the broadcast address, and you will be left with 254 usable IP addresses. Okay. So at first, it might seem that's more than enough. Yeah, you might not need more. Let's say if you have let's say 900, sorry, not 900. Let's say if you have 90 or 100 employees, I think 254 is more than enough. Or even if you have 200 employees, 254 is more than enough. However, there's the rub. Let's say if you have the HR department, or you have the IT department, then you have the admin department, and then you have the sales department. Let's say if you have them all, can you lump them all in a single network of 256 IP address? Absolutely not. Why? Because let's say if you need to notify HR about something, and you don't want IT and admin and sales to get involved, I mean, then lumping them in a single 254 network, that would just it won't be practical, and it can be a potential security threat as well. Okay, so instead, to give it a sense of order, what network engineers did is that, yeah, they created smaller networks. Yeah, so that HR can have their own network, IT can have their own, admin can have their own, and sales can have their own. Okay, these smaller networks, they are called subnet, and the process of dividing one network into smaller ones, this is what we call as subnetting. Yeah, I hope this is clear. So now that this is clear, let's proceed to understand a couple of more questions that we might have. That how do we divide one network into smaller networks, or how do boundaries work in such scenarios? Okay, I want to help all of you understand one conceptual aspect of it that we might have potentially missed. Okay, and once this is clarified, we'll understand subnetting a lot better. So over here, uh, we have, sorry, over here you see we have created these boundaries, right? Now essentially, once I explain you the concept behind how boundaries work, okay, so you'll have a better understanding of how subnet also works. So let's say, for example, So we have covered previously that in a binary, it has, first of all, we have understood that it has 4 octets, okay? The first octet consists of 8 bits. The second octet also consists of 8 bits. The third octet also consists of 8 bits. That's bits, B-I-T-S. B for Bravo, I for Indigo, T for Tango, S for Sierra. And together, 8 plus 8 plus 8 plus 8, that we have 32. So that means all IP address by default is are 32 bits. Yeah, I hope that is clear. So now that this is clear, let's take an example of /24 in CIDR notation. Again, if you don't know what I'm talking about when it comes to /24 in CIDR notation, please go back to the CIDR calculation and the entire concept behind it. Understand that properly, then only proceed. Then only proceed with this video. Okay. So in the /24, this especially that you see, let me ensure this is in red. This is like the baseline majority of you will be working with, okay, /24. Especially if you're working with home routers or small or medium, small size offices, this would be the default, okay? And let's keep this as a standard baseline. Let's open up our cheat sheet. Yeah. By the way, just for information, I have made some changes in the cheat sheet. That is the instructions of how to use it. Okay, and couple of other rows I've also added, but I will explain you what they mean later on. Okay, so yeah, so when it comes to /24, yeah, we mean by this. You see this one /24, the one this AC column. This is what we're talking about. We're going to keep it as a standard, okay? This is like the standard, this is like the baseline, this is like the default. So right now in this one, we are going from /24 to /31, okay? So that there is absolutely no confusion, and we are understanding this like small piece by piece. Yeah. So, yeah, let's open up this one. Yeah. So what do we mean by when we say /24? So that means this part, the first 8 bits, okay, they are, let me ensure I'm in the same, yeah. This is 8 bits, which is locked in. They don't change. They are the network part, okay? Absolutely. Again, let me drill this inside your head. The first part of this network part, it does not change, okay? The second octet is also 8 bits. Locked in, does not change. Third one also 8 bits. Network part does not change, stays locked in, yeah? But this one is the host part. Now what do I mean by host part? By host part, I mean we have like the flexibility that we need, so that we can assign it to as many hosts as we can. Okay, that is from 0 to 255. Yeah, makes sense. I'm sure you must have we have covered this on our CIDR, which means this one is /24. That because 8 plus 8 plus 8 is 24. Okay, let me just use a lighter red. Yeah. This is clear. So now that we have understood /24 and how that works when it comes to the boundary, again, let me repeat. You see this gray line that is formed between AC and AD? Anything left of it, that is the network part, and anything right of it is the host part. So this is how it works in /24. Let me just note this down. So now let's look at the shifting boundaries. Again, we are in this particular video, we are only looking at boundary shifting from /24 to /25 and so forth. So now let's go to /25, how that works, okay? So when it comes to /25, this means the boundary over here, this gray line, instead of between AC and AD, it will be between AD and AE. Now, what do I mean by that? This will turn into network, this will turn into 1, and let me just change the shade to mustard. Yep. This is how it will be. The boundary is set over here. Now, let's look at it in working. This will be 8 bits, this will be 8 bits, this will be 8 bits, and this will be 1 bit. Let me format it properly. So you see 8 bits and 8 bits and 8 bits, right? So 8 plus 8 plus 8 is 24, and plus 1, 25. So that's how it makes it /25. Yeah. Now, let's go to /26, how the boundary works there. Now, when it comes to /26, that means the boundary shifting from to AE, from AD and AE to AE and AF. So this will turn into network. This will be mustard. So when it comes to /26, this will be 8 bits. Again, 8 bits, 8 bits, and this will be 2-bit. That means it's /26. Again, 8 ones are 8, 8 twos are 16, 8 threes are 24, plus 2, 26. Let me just color code this properly. For all you neurodivergent folks there, I'm pretty sure, I hope you find the color coding really useful. Okay, done? This is how /26 works, a shifting boundary. I'm pretty sure by now you must be seeing a pattern, right? How this works? Yeah? /27. That means the boundary will move between AF and AG. So this means /27 would be 8 bits, 8 bits, 8 bits, and 3 bits. Yeah? That was /27. Let me just color code those properly. I'm pretty sure from now on you'll be able to do the rest, right? /28, /29, /30. I'm pretty sure you'll be able to do the rest on your own at this point. Okay? Fair enough? Another thing I just want to clarify is that in this cheat sheet, right, that I provided to you, I've created a replica of it in my own sheet, yeah, for my own reference. Anyway, that's, you see the one in red, right? The host bits left. Yeah. So I hope all of you must have understood how the shifting boundaries work. The one in gray you see over here, how if it's like, over here, the versus over here, how they work from time to time. Okay. So basically, this is what subnetting is all about. It's not that deep. Okay. So now, this getting back to this old example, let's say if HR has like 50 computers, okay, and IT has around, I don't know, 100 desktops, yeah. Sales will have around 45 devices, including laptop, printers, desktop, everything, and admin has 50. So that means essentially we are looking at 245 devices. Okay, 245 devices can easily fit in 254. That should not be a problem. However, how would we divide the subnet so that it's more efficient? So that, each department gets its rightful share depending upon how many devices are connected. Okay. And how do we ensure they don't overlap? How do we ensure that, the range is properly set? So this is a new concept we will be introducing. It's called VLSM, variable length subnet masking. But again, I'm not going to be deep diving into this VLSM now, because again, this is like more advanced and intermediate networking concept. So I won't be getting into it now, but just so that the word like this exists. Okay. Yeah, so I hope I hope you got an idea of what subnetting is all about. It's basically just, dividing an existing network into smaller networks. That's all it is. Yeah. So I hope this video was useful. It was easier to understand, and I'll see you in the next one. Bye.